Let's start in with Chapter 18, the final chapter of our semester. And we have a lot going on in this chapter, but it's a little more straightforward than Chapter 17. It kind of flows into our final analysis of designing surfaces and manipulating them and annotating them, showing them certain ways. So the main concept of this chapter is the name of the game is going to be a few things. The first part, we're going to learn how to combine surfaces and pasted surfaces, add modular surfaces all into one. The next part, we're going to analyze our design surfaces, the ones we learned a little more about creating in Chapter 17 and also in corridors in Chapter 9. Then we're going to do some earthwork quantity calculations, which is a very common thing in industry and also a very critical design parameter and heavily relied on with Civil 3D. The last part in this chapter, when we wrap this class up, is going to be talking about finally doing some annotations on our surfaces. So with that being said, let's get going here on this chapter. And starting on page 361, we're going to talk a little more about what we're talking about in the iterative process of design. So we just did a couple road pads, lot pads and ponds and various things in the last chapter, and we're going to begin an iterative process of we design the item, then we analyze it, then we continue to adjust it. So continuing into this chapter, we'll start by learning how to combine design surfaces with the paste function, which is pretty cool, how they place a high emphasis on that, which I agree with depending on how big your design gets. I'm going to show you some industry examples I've done that definitely didn't fully utilize this to paste the surfaces into one another, which they're dynamic to each other. But I've seen some larger projects just recently that we've benefited from this, large land development projects similar to our book example that combines basically roads with grading pads, with ponds, and all kinds of stuff. We'll learn a little bit about the hierarchy of operations when we combine these surfaces, which is pretty critical in the properties. Right here on 363, the order that the pasted surface goes in is pretty critical. So basically, a pasted surface works in the way you paste one surface into the other, and the second surface that is pasted into the first surface overwrites the first one, wherever they overlap each other on the XY location. So the pasty surface, the one that's pasted on, is overtaken by the pasted surface. And you can change which hierarchy they're in, which one would have precedence over the other. So this one, the higher up in the operation it is, the different rearrangement of the pasted surfaces means a different outcome here. So let's get into Moodle quick. We'll end with our Chapter 18 files all in here. We should have, I believe, 6 multiplied by 2, 12. So we have all the completed files once again. I'm back in the first file of Chapter 18, learning to combine surfaces. We'll talk about some industry examples later on into this chapter, both in AutoCAD format, DWG format, and also in their final printed PDF plan set formats. Because what good are all these drawings if they don't get into a final presentation? That's most of the goal of what we've been doing this whole semester. So in 18.1, we're basically going to create a final surface combining many surfaces of the lot gradings, the road elevations, ponds, and other smaller daylight areas. So let's start by going into the left viewport here. You notice right away the line weight thickness is on. You can turn that off if it bugs you. I'm going to leave it on for now so it really emphasizes the feature line thicknesses of the blue, the green, and the red. There's some small little surfaces and ponds and stuff. Looks like we have a little parking lot development starting to be designed up here in the kind of clubhouse HOA area. But let's start by going to tool space, into surfaces, and we'll look at the surfaces we have in the drawing. This is always a good thing to do anyway, to see what you all have. So we're going to create our surface first by going left data clicking surfaces and right clicking and saying create surface. We're going to create our pasted surface called FG final, where we're going to combine them all. And we're going to call it that. Description's fine. We'll give it a Civil 3D surface style of 1 to 5 contours design. There's a certain one from the meters too, as always. And let's hit OK. And now that surface is listed in Prospector. We could also go through the ribbon to do this, but there's a lot of ways to right click, as we've noticed, whether it's graphically in our view areas or also in our tool space prospector area. Certain things you can right click and create them here as well, certain Civil 3D objects. So there we have it started. And we're going to stay in the tool space tree here to get you a little more familiar with the tree. I know we've been bopping in here a little bit this semester, but not quite as much as you've been learning a lot more about the ribbon in general. We'll go into edits. So a surface has certain definitions. We remember a little bit from chapter 4, 3 and 4, how to build it. Certain datas build it, files from the background, elevated contours, break lines, could be a variety of objects that make a break line, different drawing objects, points, lines, text, various other things we won't go into here. Edits are a big core one. So you have what defines it and builds it. You have what edits it, and you have other tertiary datas that you can bring in, point files, point groups, point files being external files. Point groups are within this drawing. We're going to go into the edits area, which every surface of any size is going to have some edits, as well as what defines it. It also has what defines it with edits. Right click edits, and you can get all your edit options here by the right click as well. You can get to these same options if you click, say, a surface, and you have options come up on your contextual ribbons with surfaces. So you click your noun first, and you get your verbs now. So we have our properties and adding data to it, which we saw kind of these items in our tool space just a second ago. And then you have your edit options as well. This is Civil 3D 2022. And that some of them are more complex than others. Some of them are one data operations at a time. But here's the same kind of things you were seeing when I right-clicked. We're going to learn a little more about some of these other things too, this chapter. I'll go back to tool space. We'll right-click and do the same thing here. But we're going to say paste surface. We're going to select the surface to paste into this surface we just made. Remember, it's a blank slate right now. We'll pick lots exterior first and hit OK. Give it a second. So we can see some of the contours in the red appear. This is the beginning of our surface, our final combined surface. Zoom in a little bit. You can see them a little better in the red. The lot gradings of the exterior of the whole subdivision or the land development. So to go back to there, we'll go a different route instead of through tool space. Let's click on the noun, the object, and we'll go through the ribbon this time. So as I did before, I selected the surface, which is in blue, contextual ribbon with options for it. And it's the one we just made. You can see it there in the contextual ribbon as well. We'll go this time to edit surface this way, and we'll access it through the ribbon. And same options, but we're going to keep going with the same one, paste surface again. This time in our select surface to paste dialog box, we're going to pick another surface. We're going to pick now road FG, which has been built from one of our corridors. Okay. Takes a while. Not too bad. It pasted in this road contour, these road contours now into this surface. See that? Looks great. As this final surface is coming together. So we'll repeat the same steps, but we're going to add more surfaces. So I still have the surface selected. Therefore, I have my contextual ribbon involving the surface open. Let's paste more surfaces. And this time, we're going to add the pond surface. Okay. Let that think for a minute. It added it right here. I think that's the only spot it added it. And let's keep it surface selected. Paste another one. We'll do lots interior now. Hit OK. And that added a lot of the interior grading of the lots. You can see they got a lot more defined and slopes and drainages on each individual housing pad in this development. Okay, it's looking good. Now, let's, if you have deselected the surface, select it again, the red and blue one. Or if you have it selected like myself still, let's go into surface properties. Clicking this on the ribbon. You can also get to it by right-clicking, going to surface properties, as we've seen. Now we have information, definition, analysis, and stats. We'll learn a little more about analysis and stats later, but we're going to go into the definition tab, and we have a certain order of operations that I was showing you a little bit ago when we started this chapter on page 363. Any surface with edits, the edit operations are going to populate here. They will also populate in tool space if I get out of properties here. So I clicked on the surface, they're also here. Here they can be more deleted out fully and out of the surface definition. Think of that as a permanent move. If I go this route and I have it selected, I'll go this right-click method to properties instead of here. Just multiple options always. This is more of a temporary. We could delete them out of here, remove them by right-clicking, or if we just click this checkbox, it would only temporarily remove that edit operation. We could add it back later with our checkbox radio button. There also is a certain order of hierarchy, and that's very important how these surfaces function with respect to each other. It wants us to have the lots interior added, pasted surface here. And let's just move it one at a time above the pond one. We'll hit apply. Let that apply. We'll say rebuild the surface. We'll leave this open. OK would leave us. OK, it changed how the lots graded with each other. So we could do that one more time. We'll go back. Rebuild the surface. Has a different definition. So basically this interior lot overtakes whatever the pond has. In this case, so the one on the bottom is the dominant one. The one on the top is overtaken. Okay, so we want the pond to be the top dog here to overtake all. Let's hit rebuild, and the pond will overtake it because we want that pond to show. We want this to nullify whatever the surface has going on for the interior lots portion. We didn't grade out the pond as a surface here. We left this area kind of void. So by putting this on the bottom, the surface pond, the one closest to the bottom in this hierarchy overtakes the one above it. It's a little backwards. You usually think top is best, but the ones going down overtake the ones previous in the order of operations on surface edits here. So our surface looks good for now. We're going to add one more piece of data to it though. So if you still have your surface selected, it's totally fine because we're going to add one more operation in the paste function, but let me select it again. And go to edit surface, paste surface. We still want to add this surface here, this lot daylight surface. We'll hit OK. It's a small little silver surface on the outside, as we can see it filled in here, daylighted in some areas on the exterior of the lot. So basically between lots 73 and 76, it added a little daylighting, grading, separate surface that just graded out to existing. So this is not a bad move to keep surfaces more simple, develop them in a modular fashion, away from each other, linked to each other in some ways. It's not always the worst. I'll show you some surfaces really quick that I did all in one because they were on one kind of tight site. There's a lot of ways to do this. This isn't a bad way how they did this to promote a more streamlined design, a less corrupt drawing. Areas that you grade with feature lines or grading objects kind of stay segregated, like the road, to keep it. You can get some really unique, we'll just put it this way, errors sometimes the bigger the surfaces get. So this is not a bad move how they did this. We'll go to the book and talk a little more about it. And there's just some different things. Here was basically this is in a 3D view of it in a rendering state, rendered kind of shape state in a 3D ISO view. This is kind of showing that whole exterior. This is some of the interior ones in the middle. Looks like little elevated mounds. Here's our pond between lots 69 and 70. And here was our whole lot daylight the surface used, kind of the main one created from our corridors in Chapter 9 region. This is kind of its own little animal. And just this little tiny sliver daylight piece called lot daylight that we added at the end that pasted them all together to make them all one big pretty picture here. This is a more 3D object view. Also, to see that, we could select the entire surface, like any Civil 3D or object. You can select it, and you can go into Object Viewer, or you can right-click and go to Object Viewer of almost anything. And we'll look at this object similar to how the book showed it. It's a little hard to see if it's flat, but we can change the style to shaded to kind of see what the book was seeing. We can see all of our little graded pads and roads and 3D stuff going on here. So this can be done with a lot of different 3D objects or Civil 3D objects to kind of just check your triangulation, check your 3D design. Even if it's in one monocolor, it can help you visualize if your triangles are doing the right things and your contours are flowing in the right ways. So that's Object Viewer. You can use it for about anything. We can use it for pipe networks too. So if I pick one pipe and right-click, select Similar, I can totally do an object view of all these pipes. I'm selected. Here's all these pipes, stormwater or sanitary pipes. Nothing special, but you can grab many things and look at them in Object Viewer at once. It's sometimes a lot quicker and more functional. Not as editable, but viewing-wise, a lot quicker and on its toes than some of these 3D views like this. I use it a lot to analyze my surfaces I build. So let me go into a few drawings that I've done, some various surfaces. Here's probably simplest one. We did some site design for a few storage sheds, one here, one here, one here, and some interior lots. We have a lot of annotations, and our contours are kind of at a 1 to 5. Let's change them to something a little more drastic at 0.2 to 1 so you can see the design. Oftentimes I'll do that to bounce between what I want to see. Just turn them a little tighter so we can see how I designed the little basins, watersheds. So basically where I want the water to go. I pick a point and say this whole area is a watershed or a catchment. It's an area that drains into itself, or any drop of water would, in a theoretical zone, would go to one point. Catchment area or watershed area. And this is just me grading this out, and I have my surface labels here. My surface contour labels here showing the contours, and my surface slope arrows here showing general slopes, perpendicular, and the one directionality function. This is, and I have a lot of grading objects out here that I graded some ditches at 3 to 1 and 8 to 1 slopes and various things moving along the building to create a drainage ditch here on the outside. This was one job. The final plan set looks somewhat like this. So we'll just look at it real quick. It has a site control sheet and 2-dimensional callouts, and then a bunch of 3D callouts as it was printed in paper space. All these things plotted for a final beautified looking surface and presentation and elevations and slopes and all kinds of stuff. And we go into a little section view I did across the site. It's really a profile view, but it's really more of a section view hybrid. With a profile view, I showed the overall grading of the flat pads with the grading in the middle to the sumps in my 2 lanes between the storage units out here and these deep ditches I made here. And the dash line is the existing map ground as it slopes down to the southwest here or to the left. And my thick line here is my finished grade, my design ground to merge in. It looks like a well-balanced site. As we start to learn, a balanced site with surfaces is something that has an equal amount of fill, scenarios where it's above existing, and cut with the native soil, areas where material needs to be moved from the existing ground. It's one of our factors into designing good sites is to balancing them between cut and fill. And typically we have our details showing our asphalt sections and various other details. That's one site. We'll go to yet another one that gets a little more complex of a hotel I did. And I turned this surface onto its finer one with triangles. So it's a little exaggerated. It's definitely a lot flatter than this in real life, but this is showing it at 0.2 to 1 minor to major contours. And we have a lot more callouts here, calling out curbs and elevations and ramps and all kinds of stuff. Various contour labels and contour slope labels. And this is my grading design. And so I have different layer states that I bought between. This one's more for my grading. I also have different layer states I'll show you in my next drawing that turn on 2D and 3D stuff quickly. So the last job I have here is an even bigger, more complex site that has even more annotations, almost too many. We zoom in here. We can see we have quite a bit of busyness going on. I have almost everything turned on, 2D, 3D, aerials, Koga points, all kinds of stuff. I'm going to go to my layer state manager by typing LAS. It's also in our home tab up here, and going into it this way. Manage layer states. I have many made so I can bop between views. I have one here with everything on, essentially. And I have one here that goes into my 3D modeling. So let's start with all the demo stuff. I got everything demoed out I wanted to in the existing site. Isolate these things, and we'll go to my next layer state. I got all my 2D line work. I started dialing in my 2D line work before I started grading out the surface. I had to get everything just dialed in so I could quickly check my geometries, my distances, if everything's looking good and organized and balanced on the site, if the design looks good, mixing with the architectural plans over here of this new building, especially if everything's merged in, angles are looking good, distances are looking good. And then I started going into a little more designing. We're adding some old stuff in the background to keep in mind that we're going to demo out. We'll keep going through some more of these. Layer states. This is a little too many here. Let's go to the next one. We'll take a look at our architectural plans that I have turned on and off here, checking where my doors are, my spots where my drainage needs to go off the roof and various other things, fitting my architectural plans with my civil site, really getting that squared away, checking it, moving it. And from there, we start to go to make a bunch of feature lines, which I started laying out my parking lot. All these red lines were my feature lines. I started dialing in, drafting, getting the elevations set. Well, first of all, getting them horizontally correct because I based them off these polylines, and then I started grading them out. So towards the end, as I started to build their elevations, they maintain a certain surface form in 3D. Here's their contours and some of their contour labels and stuff. I don't have all the labels on because there are a lot of them, the spot elevations, and this is just my final graded surface of very unique geometry and almost a whole city block that had to fit all along this way, all along here, and all along here to existing constraints, but everything in here was mostly redesigned. So this is an existing building up here. This is a proposed one, but this all had to fit. And this is my final surface of a mix of hundreds of grading objects and hundreds of feature lines. So if I select one of these feature lines, and I say select similar, I have 140 some in here that make up my grading. And I have a bunch of grading objects. We'll select those as well. Select more, we have 50 plus more of those. So we have almost 200 feature lines and grading objects that make up this kind of elaborate campus here for this commercial development, and parking lots and frontages and awnings and new buildings. So going into that plan set, it looks a little more like so. So a lot of these plan sets have a legends and notes or covers at the beginning, giving grand scheme things and designs and legends of what the line types and symbols are. And my demo sheet saying what needs to be demolished, moved, maintained before the site is started to be built on. And a site plan to generally give a good overview of what type of dimensioning controls and geometry and landscaping and other various things in here around the whole site. And now the kind of explosion sheet is, well, not yet, but some about my utility connections, water and sewer and various other things into my new building, maybe some fire suppression stuff. And then my huge grading plan here on this architectural D-size sheet, 24 by 36. And all my spot elevations where everything catches existing, where all there's new stuff, it has points. These are all Kogo points I made quickly with some new features. And a lot of keynote bubble notes saying what type of curve and what type of details. Very full sheet of a 1 and 2 phase full grading plan of a site. This is kind of showing you what a final presentation might look like, and then a bunch of details going into really specific detail of my civil features and sidewalks and curbs and utilities, drainages and handicap ramps, ADA, all kinds of stuff, and sections of my materials like asphalt and concrete. So that was just some plan sets to give you an idea, some final presentation as we grade these sites out. I'm in 18.2 now. We're going to look at analyzing some surfaces, and one of the main things we're referring to surface analysis. We're looking to do a couple of things. So depending on the type of analysis, we might need to color code things to look a certain way so we can quickly see what's represented in slopes or elevations. And additionally to that, we might produce what we call legends to help people determine what the colors mean, what numeric values do they have. So generally, the analysis is a two-step process. We create ranges of the analysis, slopes or elevations, and then after that, we create something in the drawing, whether it's a style of the surface or a legend to go with it to denote that. So some final presentations here's a surface of a landfill dump I did to show the differences in elevation between quarter 1 and quarter 2 of 2019. And these color codings represent to a legend showing as the color gets cooler, the more fill they have. So the more positive slopes, that's where they dump the most material for the quarter. The more red it gets, the more cut was taken out or negligible. So somewhere here near 0 where it's orangish, this is just a difference in the surface comparisons between the two, which generates a net cut and fill. So most of this is fill. We generated a net fill, so a lot more material has been brought to the site or fill, which is really quickly depicted by this surface analysis. You can quickly see, okay, wow, this whole berm area is where they brought most of the stuff, and this landfill in this time. And it's quantified here in cubic yards, which is a standard unit for earth volume is in cubic yards, which is 27 cubic yards, 27 cubic feet equal 1 cubic yard. So that's the difference there. So I'm going to go into this surface and I'm going to pick on one of the contours once again. Pick on it there. And in the surface properties dialog box, first we'll go to surface properties. We're going to start to set our analysis first. Let's go to the analysis tab now. And now we're going to select the slopes as the analysis type, not elevations in this case. So let's see, we want to see the different slopes of this subdivision. And we're going to change the value to 4 under ranges. So total ranges we're going to reduce. And then we're going to hit this run analysis. So we have these 4 different min maxes it calculates. We're going to edit these now. We're going to make them more exact. Say 2, click in here. We want these to be our exact ranges of importance. So try 34 here. Sometimes you've got to bump it up a part integer. Do it in that order. And this one you can go to the max. So we're looking, the big thing about slopes, big significant of land development, this area, it's really flat, 0 to 2%. That might have drainage concerns, for example. 2 to 10, that might be our ideal building area for most things, transportation and building. 10 to 34, this might be an area where we need a lot of walls and excavations. And, for example, whatever soil or areas you're dealing with, you might determine, hey, where's your max area? A lot of times it's over 25%. This might be an area you just stay away from and don't do any building. These are pretty common. We'll hit OK. Actually, one sec. So we have our analysis ranges set. We're going to go to information. And we're going to change the surface style to emphasize these colors and hatches to something different. We're going to change it to slope banding 2D. This has styles within it to emphasize these hatches. Now, at this point, we're going to see some different colored areas. You're going to see different colors in 371 than I'm going to have. So whatever your colors here, this is fine. You can edit the colors here by double clicking on them and picking them different. I'm just going to accept these red colors. The darker it gets in a way, the darker the berry on this one, it is more steep. So that's fine, whatever colors you have there. Let's hit OK. You're going to see different colors in your version. So this really shows where my big slopes are. So it shows where my flat spots are. My darkest color is where I have my most aggressive slopes. I wouldn't build there. Or maybe that's because I built a pond there or various other things. You're just kind of getting an idea of the most buildable areas of a land development site in this case. This is our big thing. So our surface is kind of in the front. Let's pick it and right click, and this is for any Civil 3D object. New Civil 3D objects, I always go to the front by default. We're going to send it to the back so we can actually see things under it. And we're going to go into one area of this subdivision, hit escape. Let's go to the center of lot 70. And in this viewport, well, it also was in the upper right viewport as well already, but either viewport. We're going to pick the blue rectangular feature line. There we go. And now we get our contextual ribbon for feature lines we learned so much about in chapter 17. We're going to edit it, and we're going to do the raise lower command. And we're a little high up here, so we have this thick, high slope here. We want to lower this pad. And in my dynamic prompt, I have this on, but it also shows in my command bar, as always. Let's type in -5 to lower that feature line -5 feet. So that lowers it and improves our slope there, which is great. So after that happens, the surface rebuilds and our overall pasted surface stays dynamic to all of its subsurfaces within it. Everything's all golden. And we lowered that pad, made it a little bit more manageable in slope. So I'm going to go on to the third file. We're going to learn a little bit about some hydrology tools. Mainly, as we learned about watersheds, we're going to learn about catchments. So a catchment is an area that it shows that if you pick a point on a drawing, it will show you exactly what theoretical area all around it is its catchment, or what total 2D area could drain to that point you select. So it helps us fine-tune drainage of a site, and it also helps us to see what kind of area is going to flow into it theoretically based on our beautiful survey map or design map. Same with the water drop tool. It's going to show us quickly if we place a theoretical water drop at any singular point, where's it going to keep flowing to? So it's basically showing where is our drainage going. You can put a bunch of them on here really quickly. So we got this drawing open, the third, but we're going to go to the Analyze tab this time, and we're going to pick, in this case, something we haven't done before, flow paths. We're going to pick in here water drop. Now you're prompted to select a surface. You can hit enter to pick one from a list. In this case, we want to pick the EG-FG composite. Hit OK. And in this case, it's going to make this is what the water drop layer it's going to go on, what it's going to make, what type. 3D polyline's fine. You could pick a 2D. That's fine. We'll hit OK. Now it's asking which point do we want to put our water drop. Let's go to the right viewport near lot 29. And we'll pick a point kind of near the road, near lot 29. Oh, we watch that 3D line go this way. It shows that, our drainage goes all the way down to this sump, this catch basin inlet, which is great. It's showing that works the way it should. We can add more of them. I can add a water drop here that simulates a water. I'm off the surface now, but it depends where I put it. Also, I have to stay on the surface at hand, so I'm just adding a bunch of them. We still have it open, so let's go to the southeast corner of lot 23. And let's take a look where this water drop will go. You can turn off your OSNAP with F3 or turn it off here. There we go. Let's see, it's populating a 3D line on my 3D view as well. This is showing, okay, this is where we want it to go. These water drops are going right into the flow path of this road. That's what we want. Hit escape. Continuing on in the analysis tab, we're going to go down up to catchments. And we're going to say, create a catchment from a surface this time. It's prompting us for a discharge point where we think everything is going to go to. So a point where, let's say everything gets caught at, you think it's a low point, for example, you would see what kind of catchment area it would contain. So let's go to the red circle up here of this water dropper we created, went all the way to it. Let's pick the center of this red circle, for example. The O snap, so I did shift right click to pick only one O snap for now. Pick, it's not quite cooperating. Turn my O snaps back on. Just get close to the center, pick the center, and we have some prompts coming up on the create catchment from surface dialog. So we'll select that as our catchment group. That's fine. Excludes others. We're going to pick the EGFG composite for surface. And there's all kinds of civil 3D styles we could add here, pipe networks and stuff. We're going to just go through this, let this all go. Pick standard for now on all this. Leave it as is. Hit OK. So now the blue outline indicates the shape of the catchment area that drains into this inlet location that we selected. So we knew this is kind of a low point. We're getting this big theoretical blue blob here. This is the whole theoretical area that would go, based on our design surface we've made, into this catchment area. So it's saying, hey, this is the area you were picking of your design. This is theoretically how much 2D area will drain into it in this new post-development area. It's very helpful. So that's the end of 18.3. Let's move to 18.4, learn a little bit about quick profiles, how we can use them for fast analysis to analyze our 3D design. So jumping into the fourth file, using a quick profile, if you see a big warning symbol like that, just hit the regen all or start typing in regen all to make it smaller. If it's getting on your nerves especially, which they can. So this one you can get quick profiles any number of ways. You could literally click on almost any object and right click and say quick profile this way. You have to have something selected. You could pick certain Civil 3D objects and say create a profile quickly on most all of them. Okay. Or you can not have anything picked and go to the Analyze tab and also do it. So I'm on the Analyze tab and I'm going to run a quick profile this way. Now I'm prompted to select an object. I'm going to click the heavy red polyline that crosses the pond. In this case, I want to see a quick profile of the earth selected across this line. Basically, this is a quick analysis I really want to run. And we're going to pick some options here. So verify the box next to select all surfaces is unchecked. Make sure that's not on. We don't want everything. And mainly we want the EG and FG final. Or EG and FG final. And for the design profile, let's switch the style of it to design profile, or FG final would be fine. Let me see what else they have in here. The design profile. So they're differentiated between these two profiles, okay? And let's keep it at 10:1, that's fine. We'll hit OK. We'll pick a point down here to put the profile view. Oops, it's a little close for comfort to my plan. You can move it. Give it a second. So if you click these polylines, they have grips. Well, this red one doesn't exactly. They're more static, so they're surface profiles. So they're meant to be static. My mistake saying they're not dynamic in that way. But if we take this polyline, we move it, it will update my quick profile. So that's pretty nice. I can quickly check other areas, see if I like them, and the finished grade to existing grade analysis. See if that looks about right on the building pads to the road in the middle. Just showing how dynamic this is for temporary analysis. So in step 7, let me hit escape, make sure it's not selected, this red polyline. I'm going to zoom into pad 70 through 68. I'm going to identify the green feature line that forms the backside here, this feature line. Pick it. I picked it ahead of time here, so I could run a quick profile now, or I could have went to the analysis tab and picked this first and then the feature line. You can go either direction. Quick profile grabs the same dialog box to make the quick profile. EG again, and make sure this is selected down here. Draw the 3D entity profile. On this one, make sure you have something for 3D entity profile style as design profile. So these 3D entities weren't an option on the last one we did because this was a 2D polyline, but now they are an option. So we'll see what that means. So it's going to show the feature line meshed with the existing ground surface, basically. We'll hit OK. Let's just set it somewhere in here on this viewport, right here. Kind of meshes with our top one. You can quickly see what we did. So we have the feature line here, and we have the existing ground here. So we can see that our feature line indeed matches the existing ground surface here. That's how we made it. It meshes in with it, which is great. It's just kind of verifying that this feature line is up to snuff for a certain distance. So we're just verifying our feature line does what we want it to do here. So if I hit quick save, all these quick profiles disappear. So let's go on to part 5, calculating volumes. So volume surfaces are pretty important for 2 reasons. First of all, on any site you want to see, construction is very expensive, especially land development. It's the biggest expense. So the big 2 questions you want to a lot of times answer is how much earth must be removed and of what type of earth. So do we need to bring a bunch into the site, import, or do we need to transport a bunch out of the site, export? Those are the 2 key takeaway questions, and they're very critically vetted numbers that get very nitpicked. So if you go to page 377, it produces what you call a cut and fill. So cut is scenarios where what you are designing needs to cut into the existing earth, and fill is scenarios where what you're designing needs to go down to or embank on top of the existing earth in a lot of ways. And a lot of times when I was showing you this picture here, for example, on Mark White, I was showing kind of this is a cross section of the whole site. It crossed it one slice. So this is kind of like, here it is right here. It's basically this phantom line. And this is showing a balanced site in a lot of ways. It's showing, hey, this whole area balances with this whole void area. So the dashed line is our existing grade. And we have a fill scenario here and a cut scenario here. So it's balancing very evenly, like a teeter-totter, balancing like one kid on both sides, showing a good amount of balance done here. Now, sometimes there's only so much you can do. You have certain constraints you cannot design around, or various things that get in your way, or bad soil in certain areas, or whatever. You need to haul a bunch of it out because it's junk. It's full of organic material or whatever. But depending on the site, you do your best sometimes to balance it so you don't have to have a whole bunch of construction and transportation costs hauling things in or hauling things off. So this is one huge analysis benefit of Civil 3D, and it gets used a lot, but the numbers are very critical to get right. They're very easy to get wrong, and they get very scrutinized when they're off. So this is kind of just another visual of a balanced-ish site, showing equal amounts of cut and fill on a whole cross section across the site here. And really, if I really wanted to circle it with a pen, this whole area here is a big fill area because my design ground is above my cut. This area here is a big cut area. My design is below my existing ground. So they balance these two little areas in here, balance each other out. This being the cut, the fill, and then this being the cut scenario. So these two areas balance each other out in the simplest sense in this way. Okay. So back to the fifth drawing. We're going to learn about using the volumes dashboard in here, the analysis tool, analyze tab, and volumes dashboard. And we're going to also be able to do bounded volumes, which are smaller areas within an entire volume surface. You might represent, say, little volume analyses of cut fill for each individual lot, for example. That's another thing we can do. So beginning on the Analyze Earthwork area, let's go into this drawing, and we'll start with the Analyze tab. And we're going to the Click Volumes dashboard. So we're going to get a panorama that comes up with this. Mine's a little hidden, so I'm going to stick it here, more permanent. And it should be over here on this tab. I'm going to slide it over a little bit so we can see it better. Volumes dashboard. We're going to create a new volume surface this way. So this creates a comparison surface between two surfaces. And we'll accept these default areas. And we're going to it's a tin style. Grid style could go in smaller increments, smaller grid XY shapes. They're generally very similar in quality for accuracy. We'll call this earthwork. So earthwork of the whole site, what native soils, how much we need to bring in, bring out, can we balance it between what we design and what we have existing. On this one, a lot of times I will turn these to no display because I want them to hover in the background and not be seen or heard until I want them. And then on this one, on the base surface, this is critical. So this is the surface we're going to compare against. So what surface do we start with oftentimes is a good way to think about this, that you're comparing against. Well, in this case, the existing ground, our original survey surface. The next comparison surface is whatever design oftentimes you're comparing it to, or new surface or new conditions. In this case, our full FG final, which is our pasted surface of all the above from the beginning of Chapter 18 that we made. We'll hit OK. And we're going to hit OK again. And we're going to see a little bit of thinking go on in the background. You can see this net graph right away quickly tells me cut is in the red, fill is in the green. We have a mostly not a fully balanced site. We have a lot more green than red. So we have a lot more material we need to bring in. Well, that will be net need, and then we're going to have to take off on the red. So we have a huge fill scenario here, okay? Which is somewhat similar to what we saw in my earthwork quantities, say for this landfill I did. And I did some fancy surface analysis here. I had over 75,000 cubic yards of fill brought into this landfill in this quarter, showing an analysis between what it was on basically April 2nd, 2019 to July 1st, 2019. Only went up in fill. So very similar, different purpose, but similar concept of volume analysis. So TIN, as we remember from Chapter 4, stands for Triangular Irregular Network, which is a way to create surfaces by drawing lines between 3D points to form triangles. So a TIN surface is any surface that is created using this method. When we create a TIN volume surface, Civil 3D superimposes one TIN surface over another and creates a point at each location where a triangle crosses. So all these new triangles we make are interconnected and they calculate the points. That resulting surface has its distinct triangular shapes, but its values of that surface, this volume surface we just made, is basically a surface, the difference of the two surfaces, so between each other. These differences are referred to as cut and fill. Cut when they're negative and fill when they're positive. So basically we made a volume surface showing the difference between the two, to say it in a more concise way. So we can see that we have a lot of fill in this site. So one example, we could do some design where we find ways to lower a lot of our design so we don't have as much fill. We'll come in here and we might lower the profile of the road to lower the road to mesh in with the existing ground a little better. So this green amount, this fill amount, goes down a little bit and balances a little better with the red, the cut. So we can do some various things. We can lower a lot of these pad elevations so they're not so high potentially. All kinds of little things. So now we're going to make a bounded surface, volume surface to a more specific area. Let's stay in our volumes dashboard, click our one volume surface. Let's go to this icon here, add bounded volume, to click here to add a bounded smaller area. It's taking a moment. So now it's going to ask us to select a bounding object. So when I'm prompted to select a bounding object, let's pick the parcel area label of lot 1. So let's pick the parcel area label here. That gives us our whole parcel. Let's plus sign that. This little area says, I'm just going to analyze this little area of lot 1. And that's pretty cool. It picks the whole surface area. I'll do another one of lot 2, pick this parcel. It does one earthwork 2. I can rename these. But this shows lot 2 is almost all solid fill. It's green. Lot 1 is very balanced. It shows not much fill, 50 cubic yards, which is, 5 dump trucks worth of import needed. It's somewhat more balanced. And so we can get really surgical that way, which is cool to see all the different areas of volume and very specific small zones of our design. Let's do one more for lot 3. I made another one. So this one also is just all pure fill. Let's call this lot 1, lot 2, and lot 3 to better let us remember what they're analyzing for our volume between cut and fill of design and existing ground. So now let's check the boxes between those 3 lots. You can leave this earthwork for the whole site checked as well. Cascade this down. Let's generate a report to say our cut fill of all these sites. It'll take us to an HTML. We could save this out as a PDF or print it as something else, showing a quick cut fill report of the entire site. We could rename this the entire site or whatever, and each individual lot. So this is pretty cool. It really gives us a breakdown of the type of surface comparison we have in these specific areas and overall. So that's the end of volumes analysis on part 5. Going back to some of my industry examples, here's one quick one I did. This is more just showing legends and differences. I quickly made a legend over here from my surface and elevations saying, hey, this is where all of our site is at. It's mostly around no change or 1 or 2 feet, but it showed quickly where we had some cut. We had some cut where we made some ditches here and here. So very little fill was needed on this site. Mostly was a balanced site, but I just have shown where our main bit of cut or export from the site was, and most of this site. You maybe could change the colors a little bit to make it pop a little bit different, or you change the ranges to make it suit your needs or your range of elevations. It's the same with this site. I did another one of a different area of the landfill. This one's a little more simplified. I made these ranges a little fatter, 5-foot ranges down to a 1-foot range. This is basically just to get the point across, to get the information conveyed that, hey, there was a ton of fill in this general area. Everything in this zone is probably very little change, ran over, nothing added, but this is the main area where the fill was. And here's our net fill for that quarter. So I made it on a nice title block and everything else. Let's go into the final area of this book on labeling design surfaces, which we can see how intensive that gets by some of these final plan sets. Here we have a lot of labels and slopes and contour labels and spot elevations. It's the same with this other job, which had even more going on. I have quite a few surface labels. So like we said, doing the design of the surfaces and everything else with it is only half the battle. To get it conveyed and constructed and the information palatable, we need to add a lot of annotations to surfaces and various other Civil 3D objects, surfaces not being an exception to that rule. At this point, we had one more job here. This one is that site we did a demo plan. So our legends and note sheet usually, and a demolition plan of prepping the site for design, and then a site layout. So a lot of the 2D stuff and callouts and keynotes to various features that are going to be designed on the site, planning notes, and into our surface grading. Most things vertical and what the grades are going to be. This is a pretty critical sheet. What type of curbs we're going to have, elevations. These are your surface labels. So we have different surface spot elevations and slope elevations and contour labels. This is what we're getting at here. And this is kind of the final goal of some of this stuff when we design these sites. So a smaller site here and to bigger here. So let's wrap this chapter and book up here on this last section. So labeling design surfaces. So once again, when we get up to our labels, you can always go to our annotate home space there and click on this ribbon to go to annotate any Civil 3D object, and you can pick which object here. In this case, I'm going to go to surfaces, and we got our options. So you saw these on the plans I just showed you. We had slope labels, spot elevations, and we had contour labels. So I had all three of those going. Different types of contour labels. These ones can be added one at a time or along many different contour lines or at specific intervals. But in this case, let's just do contour multiple so we can keep going. And let's just accept these styles. That's fine. We'll hit add to add the contour labels. And let's pick the surface we want to label now. It's the general order of operations. It just wants us to do in yard 2. So let's draw a couple labels like this. It goes across. And if we keep moving this around, it'll keep labeling them. That's the beauty of the multiple contours. So we can add a bunch of them. I'll hit escape to close that out. We've added a few labels, contour labels, I should say, to the design surface. Now let's go back here, leave this open. I sometimes will pin it like this, so when I move, it stays a little bit, opens up some real estate, but you can leave it unpinned. We'll do contour single. So we'll just say we want to add one contour label now. And we'll hit add. Let's pick a few contours on the Jordan port surface. We'll add it along like this. There we go. We're just adding some contour labels in an integer format. Usually contours are in a nearest integer whole number along Jordan Court. Okay. Let's change it one more time to do slope labels. Let me hit escape. Slope labels. Percentage will be fine for the label style, how it looks. We'll hit add. Let's pick the same surface we've been picking. It's asking for the surface. Let's, in this case, pick the 1 point option is generally what we want unless we want to manipulate its direction. 1 point goes perpendicular to the contours, which is usually what we want. That's the way things will usually flow. And let's just start going to the front yard of lot 2 here. We'll put some labels at the slope, generally in percentage. Add a few, that's fine. Hit escape again. And now we'll add some spot elevation labels. Let's just do spot elevation. Elevation only is fine. And let's pick add again. And we'll pick the same surface we've been adding to. In this case, let's pick the 4 corners of the building pad that we've been kind of doing. I kind of missed that one. We have 4 spot elevations. You can pick them like so and move them with grips. So I can move that after creating it if I don't like where I put it. You can also use the square grip to move it into the drag state formatting. So move it where you need to. This one, of course, is in the wrong spot, so I'll move it here. So we've basically added them to each corner, but as all Civil 3D labels, they're dynamic. So I'm going to pick my feature line here of this building pad, and I'm going to say raise lower in the edit elevations here. And then I'm going to specify the elevation difference of, what do we want? Let's go -2, so down 2 feet. That will update the surface and everything with it, as well as the contour labels. They all went down 2 feet as well, as you see. So things last, all these surface Civil 3D labels are dynamic. So that's good. When you change anything in the design, the labels go with it. Just like any of my designs here, these all stayed dynamic with my model space designs. So that was ideal. As these changed, so did these, and the information stayed conveyed in real time and dynamic. So that is the end of our semester learning. Hope that was a good, thorough explanation and start for Civil 3D, and we'll see you guys next time.